Welcome back. In this video, we are going to dive into a principle of modular architecture, one of the foundational concepts in designing scalable systems. Understanding modular architecture will help you build systems that are easier to manage, grow, and adapt as your user base expands from zero to millions. So let's get started. First, what is modular architecture? Modular architecture is an approach to designing software systems where different parts or modules are broken down into independent, interchangeable components. Each module handles a specific aspect of the system, making it easier to modify, replace, or scale specific parts of it. Think of modular architecture like building with Lego blocks. Each block serves as a distinct purpose, and you can easily add, remove, or change a block without affecting the entire structure. This flexibility is the heart of why modular systems are so scalable. Okay, first let's talk about why modular architecture is important. There are several key reasons why modular architecture is so effective for building scalable systems. The first thing is the independent scaling. Each module can be scaled independently based on its load. For example, if your authentication service gets more load, you can add more resources to that module without affecting the others. Second, it's easier to maintain. Because components are separate, you can fix or improve individual modules without impacting the entire system. Third, it's faster deployment. Teams can work on different modules in parallel, speeding up development time. Fourth, resilience. Failure in one module are less likely to impact the entire system. For example, if the recommendation module in an e-commerce app fails, users can still browse and purchase products. So, for instance, in a ride-sharing app like Uber, you might have different modules for user management, ride requests, payment processes, and driver tracking. Each of these modules can evolve independently and can scale based on the specific demands they face. Okay. Second, we need to talk about the characteristics of modular architecture. The first thing is separation of concerns. Separation of concerns means that each module has a well-defined responsibility. This means that each part of your system should focus on doing one thing and one thing it will. For example, in an online store, you might have a cart module, a checkout module, a product catalog module. By separating these concerns, you can make each module more focused, testable, and reusable. Second, clear module boundaries and interfaces. In modular architecture, it's crucial that modules communicate through well-defined interfaces. This allows different teams to work on different modules as long as they adhere the defined interface. For example, the payment module might expose an API for processing payments. As long as other modules know how to call this API, they don't need to know how the payment processing works internally. This ensures loose coupling between parts of the system. Third, loose coupling and high cohesion. Loose coupling means that modules are minimally depend on each other. Changes in one module should have little to no effect on the others. High cohesion means that related functionality is grouped together within the same module. For example, a notification module that handles both emails and SMS notification is cohesive since both functionalities are related, but that module should be loosely coupled from the user profile module so that a change in how notifications are sent doesn't affect the user data. Okay, let's talk about examples, example of modular architecture in real-world systems. The first thing that we'll talk about will be the microservices as modular architecture. One of the popular way to achieve modularity is through microservices. Microservices are essentially a way to design your system as a collection of small independent services that each handle a specific part of the overall system. For example, Netflix uses microservices extensively. They broke down their monolithic application into hundreds of microservices, each handling a specific function like a user recommendations, video streaming, or billing. This modular approach allowed them to scale globally and make their systems more resilient. Second, we have the modular monolith. Another approach is the modular monolith, where your application is structured in a modular way but still runs as a single deployment. This approach works well when starting out, allowing you to keep things simple while still having a scalable architecture. An example of a modular monolith could be an e-commerce application where different modules are for inventory, orders, and users are part of the same code base but structured separately, making it easier to split them out as microservices later. Okay, let's talk about the best practices for designing modular architecture. The first thing, which is to keep modules independent. Ensure that each module can operate independently as much as possible. This means keeping shared state to minimum and making sure modules interact only through well-defined interface or APIs. Second, clearly define boundaries. Clearly define the boundaries of each module. Identify which parts of your system belong together and make sure each module is cohesive, handling related functionality. 3. Use APIs for communication. Make sure modules communicate through APIs rather than directly accessing each other's data. This decouples the modules and makes your architecture more resilient to changes. Fourth, starting with modular monolith if applicable. If you're starting a new project, consider building a modular monolith first. It's easier. It's easier to maintain it when your application is small. And when your user base grows, you can split modules into microservices to handle scaling better. Okay, let's talk about common pitfalls in modular architecture. The first thing is modularization, like splitting your system in too many modules can increase complexity and lead to management challenges. The second, the hidden dependencies. If modules aren't truly independent, changes in one can lead to unexpected issues in another. The third, poor interface design. Not defining clear interfaces can lead to tight coupling between modules, which defeats the purpose of modularity. To avoid these pitfalls, always aim for a balance, break things down enough that each module is manageable. But don't overdo it to a point where managing the system becomes a nightmare. So, to wrap up, modular architecture is about designing systems as a collection of independent, cohesive modules. This makes your system easier to scale, maintain, and grow. The key principles are: first, separation of concerns, keep each module focused on one aspect. Second, loose coupling, reduce the dependency between modules. Third, high cohesive, group-related functionality together. In the next video, we will dive into differences between stateless and stateful services, and explore why stateless services are often better suited for scaling Make sure to give this video a thumbs up if you found it helpful, subscribe to the channel, and hit the bell icon so you don't miss out on the next video. So see you soon.